Hello and welcome to our third lesson on exploring data. Today we're going to talk about displaying quantitative data with graphs. So our objectives, we want to cover dot plots, we want to talk about describing shape. Very important, by the way, kind of goes around the structure of how we want to analyze the data, which I went through in the last lesson. We talked about state, plan, do, and conclude. So some of these bits of information I'm going to give to you will continue on throughout the rest of the course. So this issue here on describing shape, very important for the rest of the class. Comparing distributions using basis of describing shape. We'll talk about stem plots and histograms and bar charts, and then we'll talk about using histograms wisely. And that'll bring us to the end. We've got a couple classwork problems for you to do, so let's move on. All right, so let's talk about dot plots. And I'm going to give you examples. So how to make a dot plot. We want to draw a horizontal axis or a number line, and we're going to label that with a variable name. We're going to scale both axes looking at minimum and maximum values. So you want to scale that to the maximum value. And then you're going to place a dot above the location on each area or a location above the horizontal axis that corresponds to each data value. So let's take a look at an example. So I have raw data here. This is a list of the number of goals that were scored in a set of soccer games. And so I'm going to create here the number of goals scored. And here's my number line, 0, 1, 2, 3, 4, 5, 6, 7, 8. And then I'm going to identify the number of, or the count based on the number of dots that I have here. So for 0, I just have one occurrence. And then for 1, I have 1, 2, 3, 4, 5, 6, 7, 8 occurrences, if I'm not mistaken. So then I have 8 dots above the 1 value on what we'll call this, we'll say the x-axis, or this number line. And then 6 for 2, 7 for 3, 3 for 4, it looks like 6 for 5, 1 for 6, 7, and 8 each. So here's my dot plot given raw data, and I'm plotting each of the instances, so each of these dots corresponds to the number of goals scored in a given game. Okay, so basically this is a dot plot. All right, so we want to talk about describing shape, and we're going to use a dot plot to describe shape. So let's talk about this dot plot again, and we're going to talk specifically about shape, center, and spread. So again, this is very important. You're going to be talking about shape, center, and spread throughout the course of the year. All right, so shape talks about the main features of the distribution. We talk about symmetry and skew, or skew. And then we talk about whether or not the distribution is unimodal, bimodal, or multimodal. And you'll recall from your statistics set on mean, median, and mode. And mode is a location where there's the most number of instances. So this relates to that definition. So uni means 1 high peak, bi means 2, and multi means more than 2. So we'll talk about symmetry and skew. We'll talk about unimodal, bimodal, and multimodal. In the center, we're going to refer to mean and median here, but mostly median. And then the spread, we'll talk about range and then also outliers. All right, so we're going to use that example and some other examples to give what we just talked about some depth. All right, so we want to talk about describing the data with symmetry and skew. And so typically in life, things are not perfectly symmetric. So we say they're roughly symmetric for symmetry. So if you take a look at a list of a dot plot, a list of die rolls where you had 2 die and you rolled the die and you ended up with a sum, and the sum value is going to range between 2 and 12. And of course the number of rolls for 7 should be ultimately higher in general for any distribution if the distribution is large enough. And we have a distribution that's roughly symmetric, meaning to the left and to the right it looks pretty even, and I can say that the line of symmetry would be right around the sum that equals 7. So symmetry or roughly symmetric is represented by this first example. And then a stem or a dot plot that is not symmetric is represented here, where I have more of the occurrences to the right of the dot plot, which means that there is a tail, or the long short end, to the left. And we're going to say that in this case it is not symmetric and it is skewed towards the left. So this is where people commonly make an error just because they consider skew as being where the majority is, but in this case it's where the tail is. So in statistics we're going to talk about skew in relation to where the tail is for the set of data. So in this case the skew is towards the left or towards the tail of the data set. So we can have it skewed right or left. In this case it's left, and the top we say it's roughly symmetric. All right, so then another discussion we want to have about shape is how many modes it has. In this case, we're just going to take a look at number of peaks. And we can see that this is bimodal. We have two distinct peaks here in this set of data. So we say that this is bimodal. So unimodal would be something that looks like either one of these two graphs. I have a peak here at 90 or a peak here at 7. And multimodal would have more than 2 peaks. All right, so if we go back to take a look at the shape, we can say that the distribution is not symmetric, meaning it's not equal to the left and right. It is unimodal here around 1, but then to the left or right it's not symmetric, and you can see it's skewed right towards the tail. All right, so that's how we would describe the shape. Center is the value that divides half of the count of the values. It's called the median. The median in this case is 3. We could also describe the center by the mean, which is the average of the values. All right, spread tells us the variability or the range of the data, and the spread is from 0 to 8. So the spread is going to be 8 from 0 to 8. And then the outliers, so the spread would be 8 minus 0. The outliers are individual values which are far outside the main range of the data. And potentially we could say 6, 7, 8 might be outliers, but they're not in this case. There is a mathematical definition to determine an outlier, and we'll talk about that in the next section. So from here on out, I'm going to ask you about outliers, but it's just now your conjecture. I'm not going to mark you right or wrong at this point, but you should provide some guess at whether or not there are outliers. In this case, there are no outliers. We're looking for something that's far outside of the general range where the majority of the distribution lies. All right, so this brings us to our first set of classwork, 1.2.1. And I'm going to have you take a look at this dot plot. This is a list of the number of siblings for each individual in an AP Stats class. And I want you to describe the shape, center, spread of the distribution, and any potential outliers. So what I want you to do is to copy this down, or you can pause here, and then I'm going to move on in a moment. All right, so moving on, comparing distributions. All right, so we have two distributions. This is household size of homes in the UK versus South Africa. So it's United Kingdom or England versus South Africa. And so we want to compare the two dot plots. You can see just immediately that South Africa, the range is bigger, and the number of larger household size is also larger in South Africa. But let's take a more specific analysis. So in South Africa, it's skewed to the right. So here's the tail, and it's unimodal. And the UK is roughly symmetric, and it's unimodal. The center for South Africa is, the median is 6. For the UK, it's 4. And then the spread for South Africa is 3 to 12 with outliers at 15 and at 26. And the spread for UK is 2 to 6 with no outliers. Okay, so let's talk about stem plots. All right, so we're going to talk about stem and leaf plots. We have a set of data. So the data set shows a number of pairs a typical pairs of shoes a typical teenager has. The stem and leaf plot then is organized where you put the least value here on the left. So this would be the first digit and then the second. So this data is organized into a stem on the left-hand side, which consists of all but the final digit, and the leaf, which has the final digit here. This is the final digit. So the first, if this were a 3-digit number, the first 2 would be on the left, and then the last would be on the leaf side. All right, so let's organize the stem and the leaves. In this case, I have stems 1, 2, 3, 4, 5. So I'm going to organize the stems first, and then I'm going to add the leaves 9, 3, 3, 5, 3, 3, 5, and then I'm going to order the leaves from smallest to largest, and then I'm going to add a key. So a key 49 represents a female student who reported having 49 pairs of shoes. Okay, so this is 50, 50, 51, 57. All right, so variations in stem plot, we can have a split stem. So each first digit is split into 2 for 2 sets of last digits. All right, so I have 0, 1, 2, 3. And then because I have a bunch at 0, I'm going to split that into 2 zeros, 2 1s, 2 2s, and 2 3s. Representing the 2 2 here is a male student with 22 pairs of shoes. And please notice that we include the stem even though it contains no data. So if I'm splitting for one, I'm splitting for all of them. This is a split stem. All right, next is back to back split stem plot. So I have females and males. So the first digit is here, and then the second digit is to the right, and then to the left for females. So right for males, left for females. So this is a back-to-back stem plot. So in this case, I have 4 would be the first number for pairs of shoes for males, and then 13 3 times for females. So you're reading right to left for females in this case. All right, so when and how to use stem plots. They don't work well with large data sets, so too many dots. And then we may need to round values in order to consolidate stems. So if we have some large value, we might have to consolidate that under a single value so that the spread is not too wide. Right, so this brings us to our classwork. It should be 1.2.2. So using the stem and leaf plot, compare the two distributions, making sure to discuss shape, center, spread, and outliers. So I'm going to give you a moment to copy this down, and then we're going to move on. All right, next thing we want to do is talk about histograms quickly. So I have this is a list of percent of foreign residents born by state, and we're trying to figure out how to represent this graphically. So you can see we have a large percent and different percents for each of the states. So what I want to do now is I'm going to group by class 0 to 5%, 5 to 10, 10 to 15, 15 to 20, 20 to 25%, and then 25 to 30%. I'm going to use a frequency table to create a count, and then from there I'm going to create a percent for each of the data sets. And then I can use my histogram to represent this. So percent of foreign-born citizens, first in terms of count, and then in terms of percent. So you can represent this either way. So this is one way to use a histogram. All right, so moving quickly on, so just a brief overview of histograms and how you might organize data in order to represent them. I want to talk about using histograms wisely. Difference between bar graphs and histograms depends on the type of variable. For histogram, distribution is of a quantitative variable. Bar graph is categorical, and I'll give you an example. Horizontal axis for histogram is units of measurement for that variable. And the bar graph identifies the categories. And then histogram, no spacing between bars. And then a bar graph, there's spacing. So let's take a look real quickly. I have a histogram on the left and a bar graph on the right. You can see there's no spacing here, spacing for bar graphs. a quantitative variable here for histogram. I have the categorical variable here for a bar graph. So again, quantitative versus categorical, units of measurement versus the category, and then spacing versus not, histogram versus bar graph. All right, thanks very much for joining. I need to end. We're at our time limit. Please come and join us next time when we begin our discussion of describing quantitative data with numbers.